Take a look at how we write some chemical compounds. One of the first ways that we covered in class is a binary, which means two elements that are ionic, which means that we have at least one metal. Ionic is at least one metal. Molecular means that we have all nonmetals stuck together. Now here we have some examples of just the word formulas. Okay, cobalt iodide. Now we have to pay attention to naming. Because cobalt is listed first and is just the element name, I know that we're talking about the cation of cobalt. Cobalt has a Lewis dot structure of CO with two dots on it. Okay, it's element 27. It's 4s2, 3d, 1, 2, 3, 4, 5, 6, 7. Okay, so Lewis dot structure like that. It's much easier to lose those electrons than to gain 6 more to satisfy the octet. Now we're going to combine that with iodide. Now I know that's a negative charge because of the IDE ending. Okay, it's just the single element, and it has a Lewis dot structure of, if I just write it up here, 1, 2, 3, 4, 5, 6, 7. Much easier to gain 1 electron than it is to lose 7. Now, just looking at the Lewis dot structure, 1 cobalt can donate its electron here. We'll need another iodine, or iodide, to accept the other electron there. So I know I'm going to need 2 iodines for every 1 cobalt. So if I combine this CO with a 2 plus charge with iodide with a -1 charge, we can use a swap and drop method. The 2 will go down here, the 1 will go over here. So it'll become CO I2, cobalt iodide. Now take a look at zinc sulfide. Zinc is this Zn with a 2 plus, and we're going to combine that because sulfur is in a column 16, we have a -2 charge. We're going to swap and drop. Don't forget to reduce. Okay, we can factor a 2 out of each of those, so it becomes ZnS. Now don't get thrown by words like this. Calcium is okay, but phosphide gets intimidating for people. IDE, remember, just means the single element as a negative charge. So phosphide is P with a -3 charge. Calcium is a Ca with a 2 plus. Swap and drop. Ca3P2. Okay, so nothing to it. Just remember to reduce when you can. Now, as we look at this, we'll see some examples of, again, just ionic compounds. We have calcium and sodium are metals. But if we take a look at magnesium phosphate, we see an ATE ending. So I simply write magnesium with a 2 plus, and here's where you need to know your polyatomic ions and their charges. PO4 with a -3 charge is phosphate. Swap, drop, reduce. That becomes Mg3. This 3 goes down to magnesium. The 2 goes over to the entire phosphate. So Mg3, PO4, and that entire phosphate has the 2 from magnesium. Okay, so nothing different. Perchlorate, the only thing that's different is per means hyper. Chlorate is ClO3. 1 more, or perchlorate means 1 more oxygen, so it's ClO4 with a -1 charge. Sodium is Na with a +1 charge. So you swap, drop, reduce, NaClO4. Now a lot of people will want to just put parentheses around the polyatomic, so you see it as perchlorate, not sodium chlorine oxide or anything silly like that. Now, there's some special naming, and I'm just bringing these up. Make sure you keep in mind, copper, we will always, always, always use copper 1 or copper 2. Now, what we have to do is we have to be careful. If I write something like copper sulfide, I don't see a 2 here from the sulfur because there must have been a 2 here. I would name this as copper 2 sulfide. Even though I don't see any 2 over here at all, we don't see that because it factored out. CuS would be copper 2 sulfide. If I have Cu2S, this 2 came from sulfur, this 1 came from copper, so that would be copper 1 sulfide. Be careful. Another thing that could give us some problems, if I take a look at lead, okay, if I write Pb, let's say SO4 we would be tempted to call this lead 2 sulfate. But what we have to remember is sulfate always has a -2 charge. I don't see that 2 there because it must have been factored out. If there was a 2 there from sulfur or sulfate, this must have been a 4. So be careful, PbSO4 2 was lead 4 sulfate, not lead 2. Now, molecular naming. Molecular compounds, we never reduce anything. We just use these prefixes we talked about, and we had some examples that we talked about in class. So I see nothing but nonmetals stuck together, so I simply name it. I have 2 sulfur, so I would call this disulfur. I see 6 fluorines, so that's hex fluoride. If you have hexa or hex fluoride, I'll accept either one. Now notice here we have only 1 carbon. I wouldn't write monocarbon because we only write mono for anions only. So I just simply call this carbon. And I see 2 oxygens, we would call that dioxide. Now sometimes you have to just stand back and use some common sense because you look at CO2, you've always named that carbon dioxide. Here we'd have dinitrogen. This looks weird, but I have tri, and then we just name it IDE, ending IODIDE. Dinitrogen triiodide. It looks weird, but you're right. You keep going with it. Now, acids become a little bit tricky. We have to keep in mind two special circumstances. If it's a binary acid, which means I have just 2 elements, it's a binary acid. I add the prefix hydro. I have the element name, and I put that in the blank, so I would call this chlor. And I just add that suffix of ic acid. So if I take a look at the second example, I see 2 different types of elements. So we call it hydro something ic acid. Okay, I see it's sulfur, so I put in sulfuric acid. Hydrosulfuric acid. Now that's for a binary. Okay, hydronitric acid. A ternary acid means that I have 3 different types of elements. Okay, so this tells me that I've got a hydrogen with some kind of polyatomic. The polyatomic ion I see is sulfate. If it is an 8 acid, I don't use the prefix hydro, but I simply add ic acid. So again, sulfuric acid. Okay, sulfuric acid is H2SO4. Notice that I'm naming it just after that core. I already know what form. It's not sulfurous acid because it's SO4, it's sulfate. So that's as simple as it gets. You just put in, for this one I see nitrate, hydrogen nitrate. So I just write in nitric acid. If it is a sulfate, or if it is some kind of 8, like a nitrate, I just add the suffix of ic acid. And here we'd have phosphoric acid. Now, if I would have an ite, let's see, I don't have any examples on this one. Let's turn this one, instead of nitric, let's turn this into us acid. The suffix of us means that I don't have an 8, I have an ite. So I would write this as H, and then I have nitrite, NO2. Now nitrite has a -1 charge, so I'd write H1NO2. The 1 from the hydrogen goes over to nitrite. So with binary acids, you have to take a look. Is it an 8 or is it an us? Here I have ic acid. Okay, that means I have carbon 8. Carbonate is CO3, the -2 charge. It's an acid, so I know hydrogen goes in front. The 2 goes over to hydrogen, the 1 goes over to carbonate. I would clean this up by writing H2CO3. Okay, hydrochloric acid. I see a prefix of hydro. That means I have a binary acid, hydrogen. Okay, this ic acid just completes the formula. Here's the core, HCl. It's a binary acid, you have hydro in front. So don't forget those things. Don't get thrown by things like acetic acid. There's no prefix of hydro in front, so it just means hydrogen with acid Because it's ic, it's acetate, hydrogen acetate, hydrogen sulfate, and so on. Be careful with us's, that's hydrogen sulfite, and so on. Okay, long confusing terms, hydrophosphoric acid, just means that I'm going to have hydrogen with the phosphorus ion. So I'll review. If we have some ionic compounds and it's binary, we just end the ion in "ide." Okay, calcium oxide. If it's ternary, that means we have a polyatomic. It's going to end in either "ate" or "ite." Those polyatomic ions, make sure you memorize those. Roman numerals, the elements that require a Roman numeral, lead, copper, and so on. We have molecular. Never reduce those. Remember, we have special namings based off of prefixes. Just tells me how many of each one we have. We have acids, two different situations. We have binary and ternary. If we have ternary, we have ic acids for ates, us acids for ites. If it's a binary, we add the prefix of hydro and something ic acid. Good luck on the test. It's a lot of rules, but we've been practicing a lot, and hopefully this will help.